what we're going to do is we're going to be showing you some code. So we've recorded a video going over the code and the data that we're sharing with you, but I will also give you an overview of what that looks like in the repo that we shared. So if you've been following the webinar with us, we've been hosting our code contributions under github.com/civilmaps/cm-hal, HAL for hardware abstraction layer. And we have some information and scripts here related to the previous two webinars. But in particular today, we're going to be looking at a couple of scripts related to this particular webinar. So under scripts, webinar 3, the first script is very basic. It would allow you to get your data. So make sure you clone our repo and you run this script. And essentially, it's getting some ground truth data in JSON and some camera frames as a zip directory, and then unzipping those and manipulating them a little bit. So this is about 1.5 gigs of data that we're sharing with you today, along with a Python script that will show you how you can work with sensor fusion within the Civil Maps stack. So I'm going to show you now a video that we've recorded with Scott yesterday going over the code and what that code can do for you.
We've put together a lab to demonstrate how to use the map information in a case where you're trying to identify the state of traffic signals. In this example, we have a bunch of frames from that video earlier where the vehicle is traveling in the left-hand turn and then does a left-hand turn, and the signal is green. What the map provides is an outline of that signal directly in front of the lane that relates to that left-hand turn. This is the image here. So you can see it's turning left, and the color scheme's a little weird right now, but there is the lane that's just pertaining to this left-hand turn, and then there's another signal that is for the vehicle's going straight, and so that's not what we care about. So in this lab, that bounding box information of this left-hand turn is used in these images. So here's the one without any bounding box. And here is actually that signal being outlined in green. And what this helps is now the vehicle can just focus on that area of the image and just look to see if the signal is red, yellow, or green, instead of scanning the entire environment. You can see how helpful this is in this sort of image where there is another signal, and it's a complex environment. So what this lab does is first it loads in all these images, and it loads in all of the bounding boxes. Right now it's just very simple as a demonstration, and it loads in the bounding box around this one signal. So here is this with the bounding box, and then here's another image with just that signal cropped. Here you could do some basic image processing to extract that this is green and not in a red state. And then here's another image where it's that same signal but with just a little bit of buffer. Okay. The goal of this lab is for you guys to actually see if you can extract the state of the signal, that it's green, and to just sort of go through that process of doing image processing, doing that processing, but having the context of the map to help out. So I'll just do a quick walkthrough of the code. There's two input data. One is all of these camera frames that are ordered by time, and the other is a JSON file that contains all of the pixel outlines of that traffic signal. Here for ease, I've just set a starting and end time for that one image just for ease. We can load all of the the signal information, the outlines, and then load all of the paths or the file names for all of the images. And then here it clips it so that you can just work on a short section if you want. And then it iterates through the frames, reads in the image from disk, extracts the outline just for that particular image, and then calls the process image function. I'll go up to that process image function. This is where it creates those different images just for the demonstration purposes. The original image, it does not have the bounding box. This function gets the image with that green bounding box. And then these two functions get a cropped image, the first one without a buffer around the signal, and the second one actually does have a little bit of more of a buffer. And the buffer is important if there's any sort of error in the sensor alignment. So if the camera is not completely aligned with the trajectory or the vehicle origin, or if there's a distortion on the camera, it's helpful to have a little bit of a buffer so you look around, and if it's not completely centered, it's fine. The other issue is if the localization is not absolutely precise, then the bounding box is not going to align. So I'll bring that up so you get context again. So that's this image. So you can imagine in localization, for example, if you are not positioned correctly and you look up that map information and it's not correctly projected onto this image, then you're actually not going to be looking right at the signal. You can be looking either, let's say there was an error in Z, you'd be looking above the signal and not actually at it. The other thing to note is that the localization needs to actually be not only the position in XYZ, but also the orientation of the vehicle so that it lines up. Because if the heading of the vehicle is off, even by a degree, and the signal is 15 meters off, then you could actually be looking at the wrong signal and be confused. Okay, so this just loads in these images and then shows the images. And kind of the to-do for the lab is, can you iterate through all of these images and try to extract the state of the signal? Is it green? Is it not green? And the key point is keeping in mind how much easier it is to do it when it's cropped and how much lighter weight it is to process a cropped image where you know exactly where to look than it is to search through the entire image, try to distinguish which signal relates to your position, and then calculate the state. So give it a try.
All right, great. Well, thank you, Scott, for the video. What we wanted to give you is some data and a way for you to just prototype a little bit with the sensor fusion from the map. So the map would be essentially giving us the boundaries around different objects in different sensor frames, and then that should simplify the work around trying to figure out what is the state of the infrastructure around us. So is a lane occupied? Is a signal green or red? Are there pedestrians at this crossing, etc.?